Here we get a chance to find the quadratic formula using completing the square. So the quadratic formula comes from the general quadratic equation. A, B, and C here are constants. So we have ax squared plus bx plus c equals 0. To be a quadratic, this term can't be 0, so a can't be 0. And we're trying to figure out the a values that make that true. And here's the strategy that we'll use. First off, we're going to try to make a perfect square. Well, I'd like this to be a square. I don't really like the a there, so I'm going to divide everything in sight by a. Can divide both sides by a. The right-hand side, that works out pretty well. 0 divided by a is 0. This works out pretty well too. That's just x squared. This becomes b over a times x. This becomes c over a. Now, to have it be a perfect square, I'm going to have to create a term here that works just right for me. So I'm going to move that term to the other side. B over a x plus something. Then this, subtracting it over to the other side, gives me, let's see, negative c over a. So I subtracted this to the other side. Now I want a term here, and I have to add it to both sides so they're equal, so that this whole thing will be a square. Well, how do you make something into a perfect square? Some of you may remember that what happens is you take this, you divide it by 2, and you square it. And that's what you have to add to both sides. So divide by 2 and square. Okay? Well, how do you divide something like b over a by 2? Well, dividing by 2 is like multiplying by a half. So b over a times a half is b over 2a. Okay? So what I have here is I have b over 2a squared. I have to add that to both sides. b over 2a squared. Now you might wonder, that's sort of an arbitrary process. Why divide by 2 and square? Well, the answer is simply because I'm looking for one thing squared. I'm looking for a complete square. Putting this term in makes it so I have x plus b over 2a. And you can sort of work backwards to check that, right? If you were expanding this, if you were multiplying times itself, squaring it, you'd get x squared. You'd get b over 2a times b over 2a, right there. But then you get these cross terms. You get x times b over 2a. Well, that's kind of half of that. Plus b over 2a times x. That's the other half of this. So if you squared this, you'd have exactly that. This is the thing that makes this a perfect square. Now, the right side's a little messier. Squaring this, I have to square the numerator, so that's b squared. I have to square the denominator, so 2a times 2a is 4a squared. I kind of like to put these two terms together. Since the denominator here has 4a squared, I just want to change this one term. So I need the denominator to be 4a squared. That means, I guess I'll multiply by 4a in the denominator and 4a. Now, if you multiply by 1, you don't change the value of a term. So this term I multiplied by 1, 4a divided by 4a, didn't change the value of it. Notice that the numerator, typically I guess I put that first, so minus 4ac, these are commutative, so you can put either first, divided by 4a squared. Okay, so now I've got 1x. Once you have 1x, right, I'm trying to solve for x, now I can start moving stuff away from the x. So maybe I'll combine these since I have the same denominator. I'll write it as b squared minus 4ac all over 4a squared. And I have this term, but I would like to square root both sides. I'd like to say, okay, well, if this side squared is equal to that, then let's see. can I say the square root of that is equal to the square root of that? Well, sort of. The sort of comes in here because squaring something makes it positive, right? So I can say that x plus b over 2a equals the square root of that if I put in a plus or minus, because I can't guarantee that this part was positive. I know the square was positive, but it could have been negative to start with. So I'm really close to home free. Let's go over here and let's move this over to the other side. So I've got x equals negative b over 2a plus or minus this square root. Now, the square root of a fraction, I'm allowed to square root the numerator and square root the denominator. So the numerator, not much chance of getting too much simpler there, but the square root of 4a squared, that's pretty handy because the square root of 4, of course, is 2. The square root of a squared is a. And you've got so much messy. This is the first time things really work out well. Both of the denominators are the same, so we get x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. That is called the quadratic formula, okay? And if you have constants in for a, b, and c, you can plug those constants in there, and this gives you all solutions to this quadratic equation.